This video is going to cover a shortcut for finding the least common multiples and the greatest common factors in a strategy I call the cake method. Let's be sure to put our date and topic at the top of the page. The essential question for this video is how can we use the cake method to find the least common multiple and GCF of a pair of numbers? We've already seen how to find the GCF and the least common multiple, of a pair of numbers. But that method can be time consuming and leaves a lot of room for error. Usually, when we want to find the multiples or factors, we make a list. So for example, if I wanted to find the least common multiple of 14 and 20, I'd list out counting by 14s and counting by 20s. I'd have to be really careful as I was doing my counting, and too often I see students make an error in addition and miss the number that the pair actually has in common, right? Or they kind of give up because it's taking so long to get there. As you can see, this one is going to take a while to get to a number that they have in common. Luckily, there's another way. A lot of people call it the cake method, and that's how I refer to it. Some people call it the upside down cake method. I've also heard some students refer to it as a chandelier method because it looks a little bit like a chandelier hanging from the ceiling. I'm going to show you this method using two numbers on my next page. And again, you can keep using your page if you still have room, but be sure you're writing everything down that is going into the video. I'm going to demonstrate this method using the two numbers 12 and 44. So first, go ahead and write those two numbers. And then we need to start to think about what numbers can both 12 and 44 be divided by. When we're doing this process and I'm thinking about what numbers can be divided by, I'd like to focus on the prime numbers, right? Something that we've talked about and will continue to talk about. But prime numbers are things like 2, 3, and 5. And there are others, of course, but that's kind of the first group that we talk about for prime numbers. So I like to see if both 12 and 44 can both be divided by any of those prime numbers. And since they're both even, I know right off the bat they can be divided by 2. To show this in our method, I'm going to actually make a little kind of a partial box around 12 and 44. And on the left-hand side, I'm going to write the number 2 because they're both being divided by 2. Right? So this is how we're starting to form our cake or our chandelier. Once we have once we've looked at 12 and 44 and we know they can both be divided by 2, I'm going to write the quotient. When I divide 12 by 2, I get 6. I'm going to write that below. And 44 divided by 2 would be 22. And that's my first layer, essentially, of my cake. But then I'm looking at 6 and 22, and I know those can also be divided by 2. So I'm going to continue the process so long as there's a number that I can divide these both by. So I'm going to make another layer here. This is why it's starting to look a little like a cake, perhaps. And since they're both being divided by 2, I'm going to put a 2 on the left-hand side once again. I'm going to look for my quotient here. So 6 divided by 2 is 3, and 22 divided by 2 is 11. I'm going to stop there for a moment. 3 and 11, well, they're both prime, so I know that. But also I know that if I wanted to keep dividing, the only thing they can both be divided by is the number 1, right? And the number 1 won't change anything if I divide it by 1. So I'm going to stop there. And it's important to go as far as you can with your division and stop only when they can't be divided by anything else in common except for 1. So this is my final layer here. And looking at my cake, I actually have everything I need now to find the greatest common factor of 12 and 44. I simply need to look over here on the left-hand side. I'm going to write the numbers on the left-hand side here, which is a 2 and a 2. To find the greatest common factor, we just have to multiply those together. And that gets us 4. That is our greatest common factor of 12 and 44. Now we can do the least common multiple. To find the least common multiple, we still need these numbers here, but now we need the other 2 remaining numbers that were left. It kind of makes a little L, which I use to remember as least. least common multiple. So I'll write those numbers, 2, 2, 3, and 11. And then once again, to find the multiple, I just multiply all of these numbers together. Sorry, that's multiplication symbols not coming across very well. So 2 times 2 times 3 times 11. Well, I know that's 132. So I know 132 is the least common multiple of 12 and 44. If I had wanted to do that with our list, it would have taken quite a bit of time. It would have been a long process, and there would have been a lot of room for mistake. I find this cake method much more easy to handle. Let's try one more, and of course we'll practice more in class, but we'll give this one more shot here in our homework video. We're going to find the GCF and LCM of 32 and 24. Using the cake method, right, we're going to put our little lines here to make our cake or chandelier. Using our cake method, let's go ahead and divide these numbers by anything that they have in common, especially any prime numbers that they have in common, and working our way down. We'll pause the video and then we'll check in and see if we have the same setup so that we can find our least common multiple and greatest common factor. How'd you do? Does your cake chandelier look kind of like mine, right? I divided by 2 and found out what was remaining after I divided 32 and 24 by 2. And I continued that process a few times until there was nothing left that I could divide, right? 4 and 3, the way they are now, the only thing they can both be divided by is 1, which doesn't change anything, so it's a good place to stop. Using this now, we have to see if we can remember which numbers, which values help us find our greatest common factor and which we would use for our least common multiple. So take a moment, once again, pause the video, and go ahead and set up what you think you need to do to find your greatest common factor, maybe circling what you need up here in the cake area. And then you can unpause the video and we'll see if we agree on our greatest common factor and least common multiple. How'd you do? Did you find that their greatest common factor was 8 and their least common multiple was 96? If so, great. You just successfully used the cake method to find the GCF and the LCM. We're going to practice this in class, but as always, go ahead and review anything you need to review before you come in and write any questions that you might have in the margins here so that you're ready to share in class.